Alright, welcome back, ladies and gents. Hope you all had a wonderful long weekend. Today we're talking about 6.3. Just to let you know, we're going to finish up 6.3 Monday and Tuesday. We're going to do a little bit of 6.4, and then Thursday we're going to have our review, and Friday we're going to have our test, okay, over chapter 6. I don't think it's going to be too hard for you guys, so we'll go from there. So your warm-up is, what is the formula for slope? Okay, you might have to go back to some of your notes in chapter 5. I'm sorry, chapter 4. I have a little cough today, so I'm sorry. But go ahead and find that formula, okay? Because we're kind of going to be using it today, but not really. So we've been talking for the last few weeks about linear equations and functions. Remember, linear equations are straight lines. They have an x and a y in them, okay? That's all the equations you've been dealing with. This means that we graph when we graph it, it is either a perfectly straight line or, I don't know why the word either is there. We graph it as a perfect straight line. Today we'll be talking about when a function is not linear, so when a line is not straight, okay? And sometimes that happens. We call this a nonlinear function, so if it's not a straight line, it's nonlinear or not linear. It has some sort of a curve to it, okay? So in order to tell if a function is linear, you have to look at its rate of change. Another word for this is slope, okay? If the slope is consistent, we're going to have a linear equation. So basically this is the change in output values, or the change in y values, over the change in input values. Input values are the x values. Okay, so rate of change is the output values over the input values, or the y values over the x values. Okay, so let's look at this rate of change problem. So they give me a table, right? X is going from 1, 3, 5, 7, 9, and y is going from 12, 18, 24, 30, 36. What I want to do is I want to see the change in the output values, or the change in the y values. So 12 to 18, what am I doing to get from 12 to 18? I'm adding 6. Okay? And then 18 to 24, I'm adding 6. 24 to 30, I'm adding 6. Now be careful, because if it were nonlinear, it would not be the same number, so make sure you're actually checking that, okay? And 30 to 36, that's a plus 6. So the change in my output values, or the change in my y values, is 6 every time, right? Now the change in my input values, or the change of my x values, if I look at this 1 to 3, that's adding 2. 3 to 5 is adding 2. 5 to 7 is adding 2. My little jumps are getting really big. 7 to 9 is adding 2. How convenient. So the change of the x values is 2. Since this is the same every time, 6 over 2, 6 over 2, 6 over 2, I can write that every time, 6 over 2, 6 over 2. Since they're all the same, this is a linear function. So I can write linear function, okay, in big letters. So that's my note down here. If the rate of change is the same every time, then the function is linear, okay? So basically, if your plus 2, plus 2, plus 2, plus 2, plus 6, plus 6, plus 6, plus 6 is all the same, you're golden. If they ask you for the specific rate of change, you do the y change over the x change, which if you reduce equals 3. So my actual rate of change for this function is 3, okay? So let's look at one that's not linear. So if I look at this change, okay, I'm going to do my little jump thing again. From 1 to 2, the change is plus 1, then I get plus 3, then I get plus 3 again, and then I get plus 1. So these are not the same every time. So basically right then I can say it's not going to be linear. But I'll do the bottom homes just so you can kind of see. Okay? 18 to 12, that's minus 6. 12 to 0 is minus 12. This gives me minus 18 here, and this gives me minus 6. Okay, so I can see these are not the same every time, right? Negative 12 over 3, negative 18 over 3, negative 6 over 1. So this is a nonlinear function. It's not going to be a straight line if I were to plot all of these points, okay? So nonlinear. Okay, usually you don't put the dash in between them, but I always forget. Okay? So again, I told you this already, the rate of change just means the slope if it's a straight line, okay? So I can, if I'm looking at this graph, this has a slope to it, okay? But it's the same every time. Okay? So that's all you're doing. If you're given a table today and they want to know if it's linear or nonlinear, you just got to do the little jumps here and decide if that rate of change is the same, okay? Sometimes they'll give you a graph, okay? So it says, decide if each of the following is linear or nonlinear, increasing or decreasing. So let's just start with the linear and nonlinear. Remember, linear just means it's a line. So take a second. Is this linear or nonlinear? Well, it's a straight line, so it's going to be linear. Linear or nonlinear? Well, it's a curved line, so this would be nonlinear. Again, linear or nonlinear? This is linear because it's a line, linear. And then this one again is curved, so I'm going to write nonlinear. Okay. So I took care of the linear or nonlinear part. Now I need to decide if it's increasing or decreasing. Now increasing means as one's value is getting bigger, the other value is getting bigger. So if my x's are getting bigger and my y values are getting bigger, I'm increasing. If my x's are getting smaller and my y's are getting smaller, then I'm probably, if my x's are getting bigger and my y's are getting smaller, or vice versa, that means I'm decreasing. And you can kind of tell. This line right here is going upwards, right? If I start, you can always start left to right. Left to right, I'm going up, 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 up. As my x's are getting bigger, my y's are getting bigger. Okay? So this one is increasing. So it's a linear increasing function. Okay? This one is linear decreasing. As my x gets bigger, so 2 goes to negative 20, 4 goes to negative 40, I'm getting a smaller and smaller y value, right? So this is decreasing. Okay? And the same can be true for curved lines or nonlinear lines. As my x's are getting bigger and bigger here, so are my y's. They're both going up and up and up and up and up, right? So this one's increasing. So just as a guess, what do you think this one's